Okay, so we're going to find the derivative of x squared plus y squared equals 36 using implicit differentiation. And you have to find the derivative of both sides. So you find d over dx of x squared plus d over dx of y squared equals d over dx of 36. So, and then you're going to find the derivative of each of these. So the derivative of x squared is 2x. And whenever you find a derivative of y, you have to multiply it by dy over dx. So the derivative of y squared would be 2y times dy over dx. And the derivative of any constant is 0. And then you subtract over the 2x because you want dy over dx to be by itself. So you have 2y times dy over dx equals negative 2x. And you're going to divide out the 2y and simplify. So the derivative would be negative x over y. Okay, so now a little harder. We're going to try and find the derivative of x squared y equals 17 using implicit differentiation. So again, you have to find the derivative of both sides. So d over dx of x squared y equals d over dx of 17. And since x squared and y are multiplied by each other, we have to use the product rule, which I have in the corner, which is f g prime plus f prime g. So we do x squared times 1 times dy over dx, because that's the derivative of y, plus 2x times y, which equals 0. And then we're going to simplify. So x squared times dy over dx plus 2xy equals 0. And again, our goal is to get the dy over dx by itself. So we're going to subtract out the 2xy. So x squared times dy over dx equals negative 2xy. And we're going to divide out the x squared and simplify. So you have dy over dx equals negative 2y over x, because we can take out an x, and that's the derivative.
So for this problem, you're going to use implicit differentiation and product rule. So the first step, as you can see that I drew already, you're going to want to find the derivative of each side. So you're just going to set up like how you would find the derivative of each side. And we're going to start with the left side. As you could see, you're going to have to find the product rule of this. So when you do the product rule, you would get 6x times y squared plus 3x squared times 2y dy over dx. And you would get this because, remember, the product rule is f prime g plus f g prime. So when you do the derivative of the first term, f, you get 6x times g plus 3x squared times the derivative of the second term, g, is 2y. And when you find the derivative of a y, so you would bring down the 2 times y, and whenever you find the derivative of y, you have to multiply times dy over dx. And for the other side, this would be a simple, this part would be simple to find the derivative. You would just get 8x and then minus, and you have to find the derivative of this, and you would have to use product rule to find that. So again, you would kind of use this type of formula for the product rule of this. So when you find the product rule of this, you get 4x, you would get 4y times 4x times dy over dx. So you found the derivative of the first term times the second term, so 4y. This should be plus 4x times dy over dx. So this next line I just cleaned up. I multiplied the terms out, and then you would just want to distribute the negative right here to the things in the parentheses. Okay, so once you do that, your main focus here is to isolate the terms with the dy and dx. So we're just going to underline those. So these are the terms that you want to put together. You're going to want to have it on one side and the rest of the terms on the other. So to keep this problem simple, the easiest way to isolate the dy dx, you would want to move this one over, and this term you would want to move over here. And you would want to move the 6xy squared over so that it goes with the other terms that don't have dy over dx. So once you subtract over the 6xy squared and you add over the 4x dy over dx, this is the line that you'll get. So the next step would be to factor out the dy over dx with this side right here that you just moved over all the dy over dx terms. So once you factor out the dy over dx, this is what you'll get on the left side. The next step would be to divide out whatever is in that parenthesis. So you would divide out 4x plus 6x squared y, and you would do the same to the other side. So divided by 4x plus 6x squared y. So once you divide each side by the 4x plus 6x squared y, this is what you'll get. And you can actually simplify it. So when you simplify it, you'll divide the top and the bottom by 2, like each term. So you would actually get negative 3xy squared plus 4x minus 2y over 2x plus 3x squared y.
So I'm going to show you how to solve this problem implicitly. First thing that we have to do is we have to take the derivative of each factor. So we do dx squared plus d over dx y minus d over dx 1 equals 0. So when we take the derivative, we get 2x plus 1 times dy over dx minus 0 equals 0. This just happens to be dy over dx. We subtract the 2x and get it to the other side. So we get dy over dx equals negative 2x. To find the slope at those given points, we plug in the x and we get negative 2 as our final answer.
So for this problem, you're going to need to use product rule. The first step that I wrote out, you're going to have to find the derivative of each term. And you have to find the derivative on the left and right side, so that's what I wrote out right here. When you do the derivative of the first term, you would get 4x. You do the derivative of the next term, you would get minus 6y dy over dx. So when you find the derivative of y, you would multiply the 2 times the 3, and that goes in front, times the y, so 6y. And then when you find the derivative of y, you have to times it by dy over dx. And the 4x I got by multiplying 2 times 2, and then x to the 2 minus 1 power. And the derivative of 4 would be 0, because the derivative of any constant is 0. So next you want to isolate the term with the dy over dx. So to do that, you would move over the 4x. So when you move over the 4x, you would subtract from each side, and this is the step that you would get. The next step would be to divide by negative 6y. So you would do that on both sides. That way you get dy over dx is equal to 4x over 6y. And then this would be simplified to 2x over 3y. So we found the derivative, but now I'm going to ask to find the second derivative of it. Of this answer. So we're going to find the second derivative. You're going to find the derivative of this answer right here. So to do that, you're going to need to use quotient rule. And to do quotient rule, you're going to use this formula right here. So low d high minus high d low. So you're going to do the bottom low times d high, the derivative of the top term. So that would be 2 minus high 2x times, and then the derivative of the low. So it's the derivative of 3y. So it would be 3 times, and when you're doing a derivative of y, it would be dy over dx, and then over low squared. That would give you 3y squared. So after this, you would plug in the dy dx that you got from the first part. So you would first plug it in right here at this step, and then after that, you would simplify. So you divide each term by 3, and then this is what you would get right here. So after that, you would multiply this negative 2x times the parentheses, and you would get this step. So now you want to eliminate the 3y in the numerator, so you would multiply times 3y, the entire thing. So when you do that, you get 6y minus 6y, you would get 6y squared minus 4x squared over 9y to the third. After this, you could factor out the 2 at the top, so your final answer would be 2 times 3y squared minus 2x squared, and then over 9y to the third. So for this problem, you're going to use implicit, and you have to use product and quotient rule to find the derivative. First, at this step right here, you're gonna set up find the derivative of the left side and the right side, and this next step is just setting it up even more. You're gonna first find the derivative of 2y to the fourth. So when you do that, you get 8y to the third dy over dx, because whenever you find the derivative of a y, you have to multiply times dy over dx. You find the derivative of the second term, and to do this you have to use product rule. So to do product rule, you would do f prime g plus f g prime. So we're going to do that. You do, this is f, this is g, so you would do f prime g, so you would get 3y plus fg prime plus 3x dy over dx. Like I said, whenever you find the derivative of y, you have to multiply times dy over dx. And then for the right side, you would have to use quotient rule. So you would do low d high minus high d low. So low x minus 1 times the derivative of the top, which would just be 1, minus high x plus 1 over the derivative of the low, 1, over x minus 1 squared. So now you want to just kind of simplify this side. You would get x minus 1 minus x minus 1 over x minus 1 squared. this would just turn into negative 2 over x minus 1 squared. So then the next step, you would want to isolate the terms that have dy over dx. So these two you're going to keep on the left side, and then you're going to move the 3y to this side. So you're going to subtract 3y and subtract it over here. So the next thing that you would get would be, the next thing that you would do, you would actually take out the dy over dx, because both of these terms have it, and they're both going to stay on the left side. So you would just factor out the dy over dx and get the y to the third plus 3x equals negative 2 over x minus 1 squared minus 3y. And then you would subtract by 8y to the third plus 3x. It would cancel, and do the same over here. And you don't want to have fraction on the numerator, you don't want the fraction to be there. So to eliminate it, you would multiply times x minus 1 squared on the top and on the bottom. So when you multiply it, you get rid of the fraction, and this is what you would get down here. And then you can actually simplify it more. You can just cancel out the x minus 1 squared. So your final answer would be dy over dx equals negative 2 minus 3y over 8 y to the third plus 3x.
And then I put minus.
So I'm going to teach you how to do this problem here and how to solve it implicitly. So far, I've set it up so we could take the derivative of each and every one. So we'll get 12x to the third plus... Okay, so I took the derivative of the rest of the equation, and this I got from doing the product rule for this. Now I'm just going to clean it up and move all of my dy's and dx's on one side and keep everything else on the other side.
Okay.
So now I'm going to factor out dy on this side, and I get dy over dx, 12xy plus 12y cubed. And that equals 12x third minus 6y squared. I'm going to divide by this.
Just get back to class. You know we need.
So now that I've done that, I can simplify. I'm going to erase this just to create some space. And I'm going to bring it over here. And now I have 2x to the third minus y squared over 2xy plus 2y to the third.
Alright, so here's our problem, and what we're going to do is we're going to solve for dy dx. And so we're going to start by taking the derivative of both sides. So having a constant on the right side is good because we know the derivative of every constant is 0, so that's pretty simple. The derivative of x to the third is going to be 3x squared, plus the derivative of y to the third is going to be 3y squared times dy over dx. Alright, and now so what we're going to want to do is we're going to want to isolate dy over dx. So we're going to start by subtracting 3x squared from both sides, essentially moving it over. And we're going to have 3y squared times dy over dx equals negative 3x squared. Then we're going to divide over the 3y squared to finally get dy dx by itself on one side. So divide this over. That cancels. Divide it over here. So now we're going to move over here. Dy over dx equals negative 3x squared over 3y squared. Now the 3's cancel, and that's going to leave us with a final answer of dy over dx equals negative x squared over y squared. Alright, so here's our second problem, a little bit more complicated, but we're going to be doing the same thing, solving for dy dx. And so what you could do on the left side with the x minus y squared is you could do the chain rule, but that'd be a lot more complicated, and since it's just to the second power, it'd be much simpler to just expand that. So that's what we're going to do. We're going to go x squared minus 2xy plus y squared equals x plus y plus 1. Alright, and now we're gonna go ahead and, sorry about that, actually a quick modification. It was plus 1 when it should have been actually minus 1 in the problem, so our problem should have been open parentheses x minus y close parentheses quantity squared equals x plus y minus 1. So we're going to expand the x minus y squared, and that's going to give us x squared minus 2xy plus y squared equals x plus y minus 1 again. And then what we're going to do after that is we're going to need to do the product rule. We're going to take the derivative of both sides, and for the 2xy, that's going to require the product rule. We'll do that when we get there. So the derivative of x squared is going to be 2x, and then the derivative of y squared is going to be 2y times dy dx. Derivative of x is simply 1. Derivative of y is dy dx, so dy over dx, and the derivative of negative 1 is 0, and the derivative of negative 1 is 0 because the derivative of every constant is always 0. So what we're going to do now is we're just going to recopy this for right now, and then we're going to do the product rule on the next line. Alright, so now it's time for the product rule. And what we're going to get from the product rule is 2y plus 2x times dy over dx. And then we're going to recopy the rest of the problem. So plus 2y dy dx equals 1 plus dy over dx. Alright, then distribute the negative, so it's going to be 2x minus 2y minus 2x dy dx plus 2y dy over dx equals 1 plus dy dx. Alright. Now what we got to do is we got to solve for dy dx, so we're going to start by trying to get dy dx on a side by itself. And so what we're going to do first is we're going to subtract this one, move it to the other side. So it's going to be 2x minus 2y minus 1 equals, then we're going to add the negative 2x dy dx and the positive 2y dy dx to the other side. So it's going to be 2x dy dx minus 2y dy dx plus dy dx. So if you notice, each of the terms on this side all have a dy dx in common. So what we're going to do is we're going to take that out. So on this side we'd be left with dy over dx, open parentheses, 2x minus 2y plus 1. And on this side we're going to have 2x minus 2y minus 1. And then we're going to divide this over to get dy dx alone. So it's going to be 2x minus 2y plus 1. Divide both sides by that. And so our final answer for dy dx is going to be 2x minus 2y minus 1 over 2x minus 2y plus 1.